So today we're going to look at how to write an equation in slope-intercept form, y equals mx plus b, when we have 2 points. So first we're going to start with a few special cases, and we're going to look at horizontal and vertical lines, which may have come up in your work so far, but we haven't really explicitly addressed. So we just want to make sure we're on the same page with that. So first let's take a look at a horizontal line. So if I want to write the equation for this line here, the first thing I would need to do would be to identify the slope. Well, there's no positive slope because the line's not going up. There's no negative slope because the line is not going down. So my initial assumption is that the slope is 0 because there is actually no change. But let's just make sure of that mathematically. So to calculate slope, we do change in y over change in x. So let's just pick 2 points on this line that we can use to calculate slope. Pick this one and this one. So the change in y between those 2 points is 0, and the change in x between those 2 points is 3. Well, 0 divided by 3 is 0, so indeed the slope of that line is 0. So the slope of any horizontal line is 0. So if we think about filling that into our equation of y equals mx plus b, if the slope is 0, then 0 times any x would always be 0, meaning in this line there is no x term, but we do have a y-intercept. And in this case, the y-intercept is 4. So that would leave us with y equals 0x, which is 0, plus 4, or just y equals 4. So the equation of a horizontal line is always a y value. This also makes logical sense because if we look along this line, we see that no matter where we go, the value of y is always 4, no matter what the value of x is. So this can be useful information if we are given a pair of points and asked to write an equation. So if I'm given the points 6, -3, and 9, -3, and asked to write an equation in slope-intercept form, I notice that the y value is the same on both of those points, which means that it's going to be a horizontal line because the y value does not change. So that means that I don't need to calculate the slope. I already know it's going to be 0, and I can just say that y is always going to equal -3. Now let's look at an opposite situation where we have a vertical line. So let's just say that I'm going to try to calculate slope of this line. So I'm going to pick 2 points. Let's say these 2 points. All right, so we're going to do change in y over change in x. So the change in y is going to be -2. The change in x is going to be 0 because the x value hasn't changed. So the slope is -2 divided by 0. Now, however, we're running into a problem because we are not allowed to divide by 0. So technically, this is undefined, which means a vertical line has no slope. The slope is undefined. So what that means is that we're not able to make an equation in slope-intercept form because there is no slope. However, we can still describe the line. If we look at the values here, we see that no matter where I go on the line, the value of x is always going to be -2. So we can describe this line as x equals -2, even though it is not in slope-intercept form. So let's say here we're given 2 points, 2, -4, and 2, 7, and asked to write an equation for that line. When I look at the points, I can see that the x value for both is 2, which means that the x value is not changing, which means we must have a vertical line, which means I can describe that line as x is always going to equal 2, no matter what the y value is. All right, so let's say we're asked to write an equation for a line that goes through 6, 6, and 0, -3. Anytime one of the points you are given is the y-intercept, remember that's when x equals 0, this is a situation where you can make your life much easier because we already know a piece of the equation. So remember that we're looking for y equals slope times x plus the y-intercept. Well, if the y-intercept is given to us, that means we already know one piece of the equation is going to be -3. So we know that our equation is going to be y equals slope times x minus 3. That means the only thing left to do is calculate the slope. So the goal of this lesson is going to be to do the calculations without using the graph. So let's think about how we can find the change in y compared to the change in x. So thinking about the fact that we always read the graph from left to right and that the change in x is always positive, if it's helpful to you, rewrite it so that the change in x is positive and makes it easier to compare that to the change in y. This is of course optional, but if it helps keep you organized, it's a good strategy. So let's take a look here. So here's the change in y. We're going from -3 to 6. That's a change of +9. And here we're going from 0 to 6, so the change in x is going to be 6. So when I take change in y over change in x, I get 9 over 6, or 3/2. So that is the slope of my line. Now I can plug that back into the equation, and I have y equals 3/2 x minus 3. Now, what I'm about to show you may seem like extra work, but the goal here is to give you some tools to check your own solutions. The beauty of algebra is you can normally know if you have the right answer by plugging some numbers back in. So, for example, here, I have the point 6, 6, and I have an equation. So this point should be a solution to this equation, meaning it should lie on the line. So if I plug 6 in for x and y, I should get a true statement. So let's give it a try. Is 6 equal to 3/2 of 6 minus 3? So I'm plugging x and y back into the equation. 3/2 of 6 is 9. 6 is equal to 9 minus 3, so I know that this point really is a solution to this equation. All right, now let's look at a situation where we have to do a bit more work. So we are asked to write an equation for the line that passes through these 2 points. So taking a look, I can see that neither the x value or the y values are the same, nor am I given the y-intercept. So that means from these 2 points, I need to calculate both the slope and the y-intercept of the line. So in this case, what you're going to want to do is calculate the slope first. So I'm going to calculate the change in y over the change in x. And remember, I want to make sure that I'm going in the positive direction when I'm calculating the change in x. This is written so that this change is positive from -3 to 2, and that change is 5. And then here from -4 to 6, that change is also positive, and it is 10. Also, if you mentally picture -3, -4, which is down in the lower left quadrant, and 2, 6, which is in the upper right quadrant, it does make sense that the slope would be positive going between those 2 points. So if I simplify that, that's 2. All right, so I know the slope of the line is 2. So my equation is going to be y equals mx plus b. And at this point, the piece I know is that the slope, or m, is 2, so now I know it's going to be y equals 2x plus b. So now I know the slope, and I need to calculate the y-intercept. So remember that these points fall on the line of this equation, which means they're solutions to this equation, which means that if I were to plug the values into the equation, I should get a true statement. We are going to use this information to help us solve for b. So I'm going to pick one of these points to plug into the equation for x and y, and then solve for the piece I still don't know, which would be b. Choose the x and y value that would be easiest to work with. So here, both of these are positive, whole numbers. That's the one I'm going to choose. So this is x, this is y. I'm going to replace y with 6 and x with 2. So 6 should equal 2 times 2 plus the y-intercept, which is still unknown at this point. Well, now I have an equation with only one variable that I can solve. So I know 6 should equal 4 plus b, which means b should equal 2. So now that I've calculated that, I can plug it back into my equation, and the full equation is y equals 2x plus 2. Now again, here's a place where you can check your own work to make sure that you have written a correct equation. So now what I'm going to do is I'm going to take the point I haven't used yet, I'm going to plug the values in and make sure I've done it correctly. So this is x, this is y. So negative 4 should equal 2 times negative 3 plus 2. This is negative 6. That is a true statement. Negative 6 plus 2 does equal negative 4. Therefore, I know that this point does fall on this line. All right, let's write an equation for the line that goes through these 2 points. Now, if you want to pause the video at this point and give it a try independently, that's a great way to use the video. All right, so first thing I want to do is calculate the slope of my equation. So I notice as I'm looking here that my x values are going down as I look from left to right. So I'm going to rewrite these points with increasing x values because that makes it easier for me to calculate the slope. So here's my change in y. Here's my change in x. If you find yourself making mistakes, mixing up x and y values, label what you're doing to make sure that you're not mixing up the x's and the y's. All right, so change in y goes from 1 to negative 5, so that's a negative change, down 6, and looks like x is going from negative 4 to 4, that's a change of 8. So change in y over change in x is negative 6 over 8. When I simplify that, I get negative 3/4. So the slope of the line is negative 3/4. And if I picture negative 4, 1, upper left quadrant, and 4, negative 5, lower right quadrant, that makes sense that the slope would be negative. So thus far I know y should equal negative 3/4 x plus b. So now I need to pick one of these points to plug into my equation and solve for b. Now, both of these x values are multiples of 4, so that'll make it easier to plug in here to solve. One's positive, one's negative, but the y values are also positive and negative, so they're both going to be equally efficient to use. I'm just going to go ahead and pick the first one. So, x, y, negative 5 should equal negative 3/4 times 4 plus b. And again, I'll caution you, if you find yourself making mistakes, label, make sure you're showing every single step. Don't try to work too hastily. All right, so let's solve this equation. Negative 5 should equal negative 3. Negative 3/4 of 4 is negative 3 plus b. I'm going to add 3 to both sides. And b equals negative 2. So now I can complete my equation. Y equals negative 3/4 x minus 2. All right, and now just to double check my equation, I'm going to take my second point here and plug it back in to make sure I'm correct. So, got negative 4, 1. All right, so x, y, 1 should equal negative 3/4 times negative 4 minus 2. Well, negative 3/4 of negative 4 would be positive 3. 3 minus 2 does equal 1. Therefore, I know that this point would fall on this line because it makes the equation true.